All right. Good morning, good evening, good afternoon, whatever time it is that you're watching this. Hopefully you guys had a good weekend. We're almost to Thanksgiving break, so we only got one more week left. And then we have a nice week-long break from everything. We only have two more lessons left in Unit 3. So we're going to get started with the second to last one today, and then we'll continue with the last lesson later on in the week. So we're going to start in our Unit 3 packet, and we're going to start on page 24, where at the top of the page you should see Lesson 7. So, what we're going to be focusing on today, as you can see, is that we're going to be focusing on comparing both the exponential and the logarithmic functions together. So, we've had lessons already in Unit 3 where we've looked at exponential functions, everything about them. We've also have, for the last two lessons, looked at logarithms, where we looked at how they look in comparison to exponential functions. We've looked at how we can like compute them algebraically or using a calculator. And we've looked at properties of these types of functions as well. So we're going to look at these functions together. So to start, in our do now for today, you have two functions. The first function is f of x is equal to 2 to the power of x. And the second function is the log of x with the base of 2. So we have a couple of x values that I have provided for us on this table. And so what we're going to do is that we're going to plug in these x values into both functions. So for example, what we're going to do is that if my first value here is -3, we're going to plug in -3 for x for this first function. And we're going to plug in -3 into the second function. And then what I want you to do is that I want you to see if you can calculate what these values are equal to. So if you don't have a calculator, please make sure you get one because this will help us for today. And then once you have done that, go ahead and compute these values for the rest of the table. Pause the video now, and then when we come back, you will see some of the answers provided. Okay, so we're back now. So all I've just done at this point is just filled in the column for the first function, taking all these x values and plugging them in. So if you did that, like for example, if you did 2 to the power of -3, you should have gotten 1 over 8, or if you have it in the decimal, you should have got 0.125. If I plugged in -2 for x in here, I should have got 1 over 4 or 0.25. If I plugged in -1, I should have got 1/2 or 0.5. If I plugged in 0, I should have got 1. And then going down the rest of the column, you should get 2, 4, and 8. Now, for this last column, things probably got a little bit interesting for you. So for the first one, you got log base 2 of -3. And we're trying to figure out what is this value. So if you're using a calculator, remember we have practiced how we can plug this into our calculator to get an answer. What you could have done is that if you plug this in your calculator, you could have done log of -3 divided by log of 2. So that's how you put that in your calculator to find the answer for this. But if you tried to do that, what might have happened is that you should have gotten an error. Okay. And if I did the same thing for -2, you probably also got an error. Same for -1. And you probably got an error for 0 as well. Now we got a lot of errors for different numbers here. Note that we got errors for negative numbers and we got an error for the number 0. That's not a coincidence. That is for a reason. And the reason why that happens, we'll talk about on the next page in a moment. But we're going to just move forward with what we got. So if I plugged in 1 into my function for x up here, log base 2 of 1, what you should have got is 0. And for the next one, if I plugged in 2, log base 2 of 2 is equal to 1. And then lastly, log base 2 of 3, I believe you should have got something like 1.59, maybe. Something like that. Okay. So we filled in all of this table. So now what we're going to do is that we're going to take these values from this table and we're going to graph both functions at the bottom of the page. So because I'm creating two different graphs, I'm going to go ahead and use two different colors to kind of show the differences between the graphs. So I'm going to use this blue marker here, and this blue marker is going to be used to graph this function 2 to the power of x. And then I have a red marker here, and we're going to use this red marker to graph log base 2 of x based on the numbers that we have gotten from our table. Okay, so if I were to do that, excuse me, I'm just trying to scroll down just a little bit. Okay, I'm just going to use the numbers that we have recorded from the top, and we're going to use this information down here. All right, so let's start with our blue marker, where this blue marker is going to be used to graph 2 to the power of x. All right, so some of the points that are given, we know that when x is 0, okay, so first off, let's go ahead and label this is my x-axis, this is my y-axis. We said that when x is 0, our y value should be 1. So we have a point right here. We also have when x is 1, our y value is 2. We also know that when our x is equal to 2, our y value is equal to 4. Okay, and then when x is 3, our y value is 8. So that goes a little bit over the grid. That's okay. And then we had these other numbers for the negatives. Like, for example, it said when x is -1, our y value is 0.5. And then if we go more to the left, what happens is that we get closer and closer to the x-axis, but don't ever really touch it. So if we were to continue this process, what happens is that our graph is going to look like this. All right, so this graph, this represents our function 2 to the power of x. So that's the first function. Now, the second function is dealing with the logarithm. Now, we don't have as many points as we did with the first function, so we'll just graph what we have, all right? So if we look at the top of our table here, it says that when our x value is equal to 1, it says that our y value is equal to 0. So when x is 1, y is 0, so that's a point right here. We also know that when x is 2, our y value is 1. So we have a point right there. And then lastly, we know that when x is 3, our y value is close to 1.5. So we're just going to put a dot right there. Okay, now if we were to continue this process, meaning that if we looked at a couple of other different numbers and we tried to place it along this graph, what actually happens is that the logarithm graph is going to look like this here. All right, so this is log base 2 of x. All right, so that is the graph of our second function. So now you see both of these two functions side by side. You might notice that they have a little bit of some similarities between them, and they kind of almost look identical, as if they're like mirroring each other. All right, so what we're going to do is that we're going to be talking about some characteristics of both of these graphs provided here. And we're going to look at, well, what exactly is similar between them and what might be different about them. So that being said, we're going to move on to the next page. So we're going to move on to page 25. So I'm going to move this side, and we're going to move to page 25. Where now, like I said, we're going to look at some characteristics about both of these functions from the do now. So let's start with identifying domains and ranges. So for that first function, let's go back to the graph just for a moment. The first part here is that we're talking about domains and ranges. Remember, domains deal with your x values, and your ranges always deal with your y values. We've talked about this for exponential functions, All exponential functions always have the same domain, whereas it is always all real numbers. So that is what we're going to write for our domain. And again, the reason why is because, again, you can plug in any x value that you want into the function. So that's why the domain is all real numbers. But the range, on our other hand, is different because going back to the graph, remember the range deals with the y values. And your y values, excuse me, the y values here don't go all the way up and down. No, no. For this blue graph, you see that the range goes from 0, because 0 is where your x-axis is located, and it goes as high up as infinity, because that arrow is pointing straight up. So that means that the range for this first function is 0 to infinity. Instead of writing infinity, I'm just going to use the symbol. Okay. Now, when we talk about the x and the y-intercept, so we're looking at where exactly does the function touch the x-axis and where does it touch the y-axis. If we look at the graphs again, for our blue graph, the blue graph is actually never going to touch the x-axis. So for that reason, it is not going to have an x-intercept. But on the other hand, we do touch the y-axis. And remember, the y-axis is actually at the point 0, 1, because when x is 0, we said that our y value is 1. So going back to our table here on page 25, we're going to say the x-intercept, we're going to write NA because there isn't one. And then for our y-intercept, we're going to write the point 0, 1. So these are some characteristics for the first function. Now let's look at the second one. So if we look at, again, if we look at this time the function in red that we drew together, now we're talking about domain and range. For domain, when we're talking about the x values, note that our x values, you can see through the table or on the graph, we cannot have any negative numbers plugged in for x into our logarithm, because every time we plugged in a negative number, or 0 for that matter, we got an error message every single time. So for that reason, the domain, because we can't use every single x value, the domain for this function is actually going to be 0 to infinity, meaning that I can plug in any number for x between 0 and infinity into this function and get an answer. But for the range, on the other hand, okay, if we look at the range here, note that this arrow pointing down, this is going to keep going down all the way towards negative infinity. And this arrow, while it is pointing sideways, it also is pointing upwards, meaning that it's going to continue to go up very slowly, but it's still going to go up nonetheless. So that means that this arrow here is actually going to be going towards positive infinity. So we have one arrow going towards negative infinity. We have another arrow going towards positive infinity. So in other words, the range for this function, it's going to touch every single number. So that means that the range is all real numbers. Now, that's the domain and range. So now if we wanted to do the same thing for the x and y-intercept, we have to look at the graph, see where it touches the x-axis and or where it touches the y-axis. Looking at our graph in red, this will never touch the y-axis. So for that reason, we don't have a y-intercept. But it does touch the x-axis. It touches it right here. And that point is 1, 0. So that means that our x-intercept is the point 1, 0. And because we don't touch the y-intercept, or the y-axis, excuse me, we don't have a y-intercept. So looking at this information from this table that we filled in, we've identified the domain, the ranges, the x and the y-intercepts for these two functions, and we have them side by side. So now what you want to do, or what I want you to do, is there are two questions that I want you to answer. I want you to answer questions 1 and 2 on this paper. It's asking, what do you notice about the domains and ranges of these two functions? And it's asking, what do you notice about the intercepts of these two functions? So take 30 seconds, answer those two questions, and then we'll talk about it in a moment. So go ahead and pause your video. All right, so you had time now to go over questions one and two. And so what you might have noticed is that for these two problems, you might have noticed that, oh, the domains and ranges of these two functions, they're just, well, opposites of each other. Meaning that if I flip these two, I get the domain and range of the other function. And then kind of similar to the x and the y intercepts. It's kind of like if I flip these two around, I get the x-intercept of my other function, or I might get the y-intercept of my other function, same thing as before. So we notice that the domains and ranges are opposites of each other, and we've noticed that the y and the x-intercepts are opposites of each other. So this last question here, what it says, what is the relationship between f of x and g of x? What we can say is that these two functions, they are what are called inverses of one another. So these two functions are inverses of each other. Now, this is actually a new vocab word. You might have heard this word in Algebra 1, or you might have heard it in geometry, but when we talk about the word inverse, right? Inverse is just a mathematical word of just saying opposite. So we say one function is the inverse of another, that means that it's just the opposite. Okay? So that's basically what it means by what we say inverse. And then we do have some notation for that as well. All right, so how we notate an inverse is that we have our function, like let's say f of x, just like what you might have seen before. The only difference is that you might see an exponent here of -1. This is just telling us, or this is just a mathematical way of telling us that, yes, we are dealing with inverses. So if you see something like this, or if you see something like this is just telling us that, hey, we are trying to figure out, or we are talking about the inverse of this specific function. So that's just the notation that we use in math for that. So now we kind of see that these two types of functions with exponential and logarithms, they're starting to become inverses of each other. All right. And that's just not a coincidence. This is a real thing. All right. So we're going to continue looking at these inverses, all right, by looking at this guided practice on page 26. So on page 26, you have a function here, f of x is equal to 10 to the power of x. And what we want to do during this time is that I want you to fill in this chart. You have these x values here. I want you to plug them into your function, see what you get. So you're going to write your answer here. Then from there, what I want you to do is that I want you to identify what's the domain, the range, and if it has an x or a y intercept. And then once you have done filled in these two tables, I want you to take this information and graph it on the right-hand side of your paper. All right, so go ahead, pause this video, take time to see if you can fill out these three items here. And then when we meet again in a couple of moments, we will actually have this entire page filled out and continuing from there. All right, so you should have time to look at these charts and this graph on page 26. So let's look at it together. So for the first part, in terms of taking these x values, you have to plug them into your function here at the top to see what you get. So I actually have those numbers provided. So going down the line here, you should have got 0.001 or 1 over 1,000. The next one, you should have got 1 over 100 or 0.01. Then you should have got 1 over 10 or zero point 0.1. Then you should have got 1, 10, 100, and 1,000. All right, so those are our y values for this function. Then when we fill out this section here, The domain, because we can plug in any number we want, positive, zero, or negative, the domain is all real numbers. The range, on the other hand, is going to be going from zero to infinity. No matter what, no matter, as you can see here, no matter how small we get, we're getting closer and closer, but we never hit zero. And on the other hand, our numbers are just getting bigger and bigger um, as our x values go up. Now, because of the fact that we will never touch the x-intercept or the x-axis, there is no x-intercept. So we're just going to write NA here. And then on the other hand, for the y-intercept, we are going to hit that right here because when x is 0, that means that you're touching the y-axis. And that means that our point here is 0, comma 1. That is going to be our y-intercept. So now comes the point of graphing everything. So I'm going to use blue marker from before to graph this. So I might not be able to graph every single point here on the table that we created together. So I'm just going to plot as many points as I can. So I know that when x is 0 or y value is 1. Now I know that we go by fives here, so I'm just going to do a guesstimate. I'm going to say 1 is maybe like right around there. We know that when x is 1, our y value is 10, so we can graph that point. And we know that when x is 2, our y value is 100. So that means that we're going all the way up to the top here. Now, if I try to plug in those numbers that are negative, like when x is -1, our y value is 0.1, you know, we're pretty dang close to the x-axis here at the bottom, but we're not necessarily hitting it, but that's okay. But if we were to continue this process, we would get that our graph, I just connect the dots here, is going to, well, be pretty close to this here. And I'll zoom out so that way you can see the thing in its entirety. Okay. So we're pretty close in terms of getting this whole graph on here. Hopefully you can see the whole thing, but you will see that this curve is a pretty steep curve, and that's okay just because our numbers are getting really large really quick. Okay. So that is going to be just the basics of graphing this function. Nothing new. We've done practice with this in previous lessons, so this should be like a little bit of a refresher for you. Now, the other thing I do want us to focus on is trying to figure out this bottom question at the bottom of the page, where the question is asking us to see if we can write the inverse function, meaning we want to write the opposite of this up here, 10 to the power of x. If we go back to the previous page just for a moment, okay, if we were to go back to page 25, note here that these two functions are inverses of each other. All right. So we said that when we had 2 to the power of x, the inverse function is, well, log of x with a base of 2. In this case here, we have 10 to the power of x. So if we want to write the inverse function, well, in that case, what we have is that we have the log of x, but the base is going to be 10. All right, so this is our inverse. And again, if we want to use that notation, we will say that this is equal to, we're going to say f inverse, okay? F inverse of x. That's how we say this. So log base 10 of x, that is the inverse of this function here at the top. Now, I am actually going to go ahead. Good news for you. I'm going to skip page 27. So we're not going to worry about this graph here. So we're just going to exit this part. So on your paper, go ahead and X this out. We're not going to worry about the inverse graph for right now, at least. So just ignore this for now. We will eventually come back to it in lesson 8, but for now, just ignore it. But at the bottom, Okay, now we're talking about inverses. Okay, so remember, inverses are opposites. So think about addition. If I were to ask what's the inverse of addition or what's the opposite, in that case, it would be subtraction. And likewise, if we went backwards, if I asked you what's the inverse of subtraction, you would say addition. Now, if we go to multiplication, the inverse or the opposite of that is, well, division. And then vice versa, the opposite or the inverse of division is multiplication. Now, we're talking about in this unit or in this lesson, we're talking about exponential and logarithmic functions. Turns out that these two functions are in fact inverses of one another. So if I ask what's the inverse of an exponential function, in that case, the opposite is a logarithm. And then if I ask, well, what's the opposite or what's the inverse of a logarithmic function, you would say it's an exponential. All right, so in this lesson, or as we continue this lesson, what we're going to focus on now is if I'm giving you one of these two types of functions, no matter how it looks, we're going to be able to actually write out the inverse of those functions. Meaning that if I give you an exponential function, we're going to write out the inverse as a logarithm and vice versa. So I'm going to show you the steps or the process of how to do that. All right. And so to help us with that, we're going to look at page 28, where this kind of gives us a guided example. Well, it's the same example that we've dealt with from the do now. All right. So the key here is that if you have, let's say, an exponential function, like in this case, 2 to the power of x, and I were to ask you what's the inverse, all right. Well, we already know that the inverse of an exponential function is a logarithm. So for that reason, we should start by writing the log of x. Now, whatever the base is of your function here, this also needs to be the base of your logarithm here as well. So note that the base of my exponential is 2. That means that, okay, when I write my logarithm, the base of this also has to be 2. So those numbers have to match. And if they don't, the math ain't mathing. All right, so just be careful and be on the lookout for that. All right. And then what we have talked about from the previous page, if you know the domain and the range for this function, then you will automatically know the domain and the range of the inverse because they are just opposites of one another. All right. So in this case here, the domain of this exponential function, well, we already said before, is all real numbers. And we said the range is 0 to infinity. So if I were to ask you what's the domain and the range of the inverse, it's the same values up here, but you just flip them around, meaning that this here becomes the domain and this here becomes the range. So the domain for the logarithm is 0 to infinity, and the range is all real numbers. So this is just the basics or the basis, the foundation of how we write an inverse of one of these two functions. Now, there are some other elements that we have to add into here, like we might be taking our functions and we might be tweaking it a little bit by adding a couple of extra pieces to that. So now what we're going to look at is partly, well, if those extra pieces are added to our functions, well, how does the inverse going to look or how's it going to act? All right, so we're going to look at that on page 29. All right, now I can understand how at the top this table here can look mighty confusing, and I get that. So to give us a better understanding of what this table at the top is saying, what we're going to do is that we're actually going to do these four practice problems together. And This will kind of give us a solid understanding of how we can write inverse functions. And then once we do these four practice problems, then you're going to have some time afterwards to work on some independent or some collaborative practice problems on page 30, kind of doing the same technique that we're going to be doing for these examples here. So please make sure, especially when we're going over this part, you are paying close attention to what I'm doing. And if you do have questions while this lesson is going through, it is going to be super important that you please reach out to me directly. So that way we can work together on kind of going more into steps on what I am doing for these practice problems. All right. So for practice problem number one, we have the log of x plus 5. And the goal here is that we want to write the inverse of this function. Okay. So to give us a better insight or to give us a better idea of how to work with these problems, there's like a series of steps that I think would be important for us. So I'm going to write these steps on the side that we're going to be using for each of these problems, and that'll kind of help you with writing out the function. All right, so the first step that I would just suggest for all of these problems is, well, first step is we're going to identify if we have a logarithm or an exponential function. Okay. So in this case, for number one, clearly because we see the word log, we are dealing with the logarithm. Okay. So that part we already, oh, okay. We already kind of know, well, if we're trying to find the inverse, well, we got to first talk about, well, what's the inverse of a logarithm? And if we go back, we said on page 27 that the inverse of a logarithm is an exponential function. So that's kind of going to be our start. Now, step two, what we need to do is that we need to identify the base. Okay. So identifying the base is going to be helpful for us because that is going to help us with starting out our inverse and how we write it. So if we look at this function here, we're trying to figure out, well, what's the base? Note here, normally we have a base that goes right here. But note here, there is not one. We have talked about when it comes to logarithms, if no base is given to us, we assume the base is the number 10. So our base here is 10. This is going to be helpful for us because now when we start writing our inverse, okay, now we're starting to write our inverse. We start with, well, since we are starting or we are writing an exponential function for this, that means that we say our inverse is going to start with 10 to the power of x because that's what we have here. Okay. So now comes the thing about, well, how do we deal with this 5 that's on the outside? Okay. So we have a 5 here. We're adding 5 on the outside of our logarithm. And now what we need to do is, well, how do we account for that in our inverse? This is where step 3 is going to come into play. All right. I'm trying to figure out the best way of how I want to write step 3. Okay. We're going to say for step 3, if we are doing operation on the outside of our function, take the inverse and move it to the inside. So step 3, I wrote a lot. Okay, we said that if we're doing an operation on the outside of our function, take the inverse and move it to the inside. So here's what I mean when I say step 3 here. On the outside of our logarithm, we are adding 5, okay? We said that the inverse of adding is subtracting. So instead of adding 5, the inverse is now going to be looking at subtracting 5. So the subtracting 5 now, we're going to move that to the inside of our exponential. And the inside of our exponential is at the top of our exponent. So in other words, what we're doing is that we're taking this plus 5, take the opposite, or do the opposite, which is minus 5. And instead of keeping it on the outside, we're going to move it now inside of our exponent. So now this here is our inverse. It is 10 to the power of x minus 5. So that is how we deal with any operations outside of our function. It's going to be the same thing as well if we have operations on the inside of our function as well, like number 2. So number 2, we're going to follow these steps here. All right. First step, we're going to identify if we have a logarithm or exponential. Well, same thing here. We have a logarithm because we can see that. All right. Step 2 says identify our base. Well, the base in this case is 4. So now when we write out our inverse, we know that the foundation of our inverse is going to be 4 to the power of x. So that's what we're starting with. All right, but we have a couple of other things that we need to account for. Note here that we have this 2. I'm going to see if I can use a different color here. We have this 2 that is on the outside of our function, and we have this 3 that is on the inside of our function. So we need to account for both of those two features. Let's start with the 2. All right, you might notice that this 2 on the outside of our function is being multiplied because that's the operation right here. So if we have something on the outside of our function, take the inverse and move it to the inside. So we are multiplying by 2 on the outside of our function. The opposite of multiplying is dividing. So that means that with our function, we are going to be taking our exponent and we're going to be dividing it by 2. So I literally wrote the division symbol here, or you can write x over 2, it does not matter. But I'm just showing you that we're just taking this 2 that's being multiplied, and now we're doing the opposite and moving it to our exponent. Now, the other piece here is that we have a minus 3, right? Because we're subtracting 3, and that is on the inside of our function. This is kind of like the opposite of step 3, so I'm going to write it here. We're going to say for step 4, if we are doing operation on the inside of our function, what you will do is that you will take the inverse and then you're going to move it to the outside. And I know that you might not be able to see all of step 4, so I'm just going to scroll down just a little bit so that way I can have all of this here. Okay, so in this case here, we have a minus 3 on the inside of our logarithm. So what we need to do is that we need to do the opposite. Opposite of subtraction is addition. And we're going to add 3 on the outside of our exponential. So that means that our inverse for this guy is 4 to the power of x divided by 2. And then at the end of that, we're going to write plus 3. And that is it. That's our final answer. All right. Now let's deal with these last two practice problems. All right. This first one here, it says that we have 1/2 to the power of 3x minus 4. So first things first, we need to identify if we have a logarithm or an exponential. Well, in this case, we are dealing with a exponential function. So if we're going to write the inverse, that means that our inverse here is going to be a logarithm. Okay. Now, we already know this part. We are dealing with the logarithm. The base is this number here, 1/2. So 1/2 is our base. Okay, and then we have x. Now, we have two things that we need to account for still. We have this 3 that we are multiplying on the inside of our exponential, and then we have this -4 that we are subtracting on the outside of our exponential. All right, so let's start with this one here, this 3. We are multiplying by 3 inside of our exponential. So that means that for the inverse, we do the opposite, which is dividing, and we're going to move that on the outside of our logarithm. So eventually what's going to happen is that this logarithm is going to be divided. It is going to be divided by 3. And then for this -4, we need to do the opposite. So instead of subtracting 4, we're going to add 4. And since this is being subtracted on the outside of our exponential, that means that we need to add 4 on the inside of our logarithm. And then for this, we're going to put this all in parentheses because this identifies that this is all inside of our logarithm. So this here is going to be our entire inverse. All right, and then we have one more. So let's knock this out. Step 1, what type of function do we have here? You should have said that we have an exponential. So that means that for our inverse, we're going to have to write this as a logarithm. Now, second step, identify the base. In this case, your base is e. So we're going to write here e. Now, we also need to account for what else is happening inside of our function. The only thing that we are doing is that we have a +3. So we're adding 3 on the inside of our exponential. So for the inverse, you do the opposite and move it to the outside. So the opposite of +3 is -3. And that -3, we're going to move on the outside of our function. So that means that our inverse here is the log base e of x -3. That could be one way that you write your final answer. Or what you might notice is that, remember, if you have a logarithm with the base of e, you can rewrite this as the natural log. So we can say also that this is equal to the natural log of x -3. However you want to write it, I leave it up to you. But that is how we deal with inverse functions. And this is how we deal with accounting for any other numbers that we are including either on the inside or the outside of our function, and how we accommodate for that inside of when we write our inverses. Okay. Hopefully, kind of going over these 4 practice problems made some sense in terms of how we deal with inverses, especially with these steps provided. But again, if you're still confused on how we got these final answers, it is going to be highly important that you reach out to me so that way we can go over this more in detail if we need to, so that way you feel more confident about dealing with this on the test for when I return. Okay, so what we have left, if we go to page 30 now, page 30 is the last page for this lesson for today. You will see that on page 30, there are 15 practice problems here. And for these 15 practice problems, all you're doing for each of these is you're looking at the functions that I give, and you are writing the inverses of each of these functions that are provided. So that's all you're doing is just writing out, well, what is the inverse of each of these functions? Your answers for for the inverses, you're going to write at the boxes on the bottom of page 30 here. Okay. So the good news is that you will not have an exit ticket for lesson 7. Your exit ticket, quote unquote, for this lesson is actually working on these 15 practice problems, identifying the inverses of each of them, and writing them on the boxes provided at the bottom of the page. So you have the rest of the class period to work on this page here. And whatever you don't finish, obviously, you need to make sure that you have completed by the next time you meet for class, because then we will check off if you completed this page so that we can get credit for it. And then we move on to the final lesson of Unit 3. All right. So hopefully this all made sense in terms of what we looked at today. I know it's kind of jam-packed in terms of a lot of information was kind of thrown your way and whatnot, but that's okay. Take this time now or these next few days to kind of look over inverses in terms of how we write them out, get this practice in, ask questions, work together, do what you need to do to make sure that you get a better understanding of that. All right. Because when we come back from Thanksgiving break and we start reviewing for not only the Unit 3 summative, but also midterms, you're going to be seeing these types of problems again. All right. So it's going to be important that we kind of get cracked down on them now and we understand how we execute this. All right. So I would say now take this time, work on those practice problems. If you have questions, feel free to ask and reach out. Otherwise, I hope you have a great rest of your day. Enjoy the rest of this week. It's supposed to be a lovely week with the weather and everything. And then the next time we meet, we will go over the last unit or the last lesson of Unit 3. So I'll see you guys later and enjoy the rest of your day.